Titan, Earth's twin built wrong. A world with weather, but the chemistry is alien. Clouds gather in a thick orange sky. Rain falls, rivers carve valleys. Waves lap against distant shores. If you only described the processes, it would sound like Earth. But on Titan, the largest moon of Saturn, the rain is methane. The rivers are methane. The seas are methane and ethane. Water is rock. Ice is bedrock. And the familiar cycle of evaporation and rainfall runs on hydrocarbons. Titan is often called Earth-like. It is. But it is Earth rewritten under different physics. On Earth, the water cycle shapes everything. Solar energy heats oceans. Water evaporates into vapor. Vapor condenses into clouds. Clouds release rain. Rain flows through rivers, erodes landscapes, fills lakes, and eventually returns to the sea. Water is not just weather. It is geology. It is climate. It is biology. Water dissolves salts and organic molecules. It transports nutrients. It enables chemical reactions. It shapes continents and sustains ecosystems. Now imagine a world where water is frozen solid as granite. That is Titan. At roughly minus 179 degrees Celsius, water ice behaves like stone. Mountains, plains, and cliffs are made of frozen water. The rocks are ice. The soil is icy sediment. Yet there is still rain. Because methane, under those temperatures and pressures, behaves the way water does on Earth. Titan's atmosphere is thick, denser than Earth's. It is composed primarily of nitrogen, much like our own atmosphere, but with methane playing a critical role. Sunlight interacts with methane high above Titan's surface, breaking it apart. Those fragments recombine into more complex hydrocarbons and organic molecules. Some drift downward as haze. Some participate in cloud formation. Some eventually reach the surface. The atmosphere is dynamic. Seasons last for years because Titan takes nearly 30 Earth years to orbit the Sun along with Saturn. During seasonal transitions, methane clouds can gather near the poles or along equatorial regions, and sometimes it rains. The revelation came through radar. Titan's thick haze prevents visible light imaging of the surface. But the Cassini-Huygens spacecraft used radar to peer through the atmosphere. What it found were dark, smooth regions clustered near Titan's poles. These were not shadows. They were liquid. Kraken Mare, Ligeia Mare, vast seas hundreds of kilometers wide. Shorelines mapped by radar reflections. Smooth surfaces consistent with standing liquid. Some measurements even hinted at wave motion. Subtle changes in reflection, suggesting wind-driven ripples. Titan has coastlines, not imagined, measured. When the Huygens probe descended through Titan's atmosphere in 2005, it transmitted images of branching, river-like channels cutting through the landscape. The channels converged into low-lying plains. At the landing site, the probe photographed rounded pebbles, scattered across the surface. They resembled river stones on Earth, smoothed, transported, shaped by flowing liquid, except the liquid was methane. Titan's hydrological equivalent, sometimes called the methane cycle, mirrors Earth's water cycle in surprising ways. Methane evaporates from seas. It condenses into clouds. It falls as rain. It flows through rivers. It pulls in lakes. But methane is chemically unstable in Titan's atmosphere. Sunlight gradually destroys it. That means Titan must have a source replenishing methane over geological timescales. Some models suggest cryovolcanism, eruptions of subsurface. Material could release methane into the atmosphere. Others propose reservoirs beneath the surface, slowly feeding the cycle. The exact mechanism remains uncertain. What is clear is that Titan is not static. Its weather system is active. The haze above Titan is another clue. High in the atmosphere, solar radiation drives photochemistry, forming increasingly complex organic molecules, hydrocarbons and nitriles, that settle slowly downward. These organic compounds accumulate on the surface. Titan is, in effect, a natural laboratory for prebiotic chemistry. Complex carbon molecules form without life. The building blocks of chemistry assemble in cold sunlight. It is not proof of biology, but it demonstrates that organic chemistry does not require a living system to begin. And then there is the cold. At minus 179 degrees Celsius, molecular motion slows. Reaction rates decrease. Water-based biochemistry would freeze into rigidity. Yet methane remains liquid. On Earth, life uses water because it is abundant, stable, and chemically versatile. But in principle, other solvents could support alternative chemistries. Methane is nonpolar. It behaves very differently from water. Membranes, metabolic reactions, and molecular interactions would not resemble terrestrial biology. If life were possible in such an environment, it would be profoundly unfamiliar. It would not breathe oxygen. It would not rely on liquid water. It might not even use structures we would immediately recognize as cells. This is speculative. There is no confirmed evidence of life on Titan. But Titan forces the question. If life requires a solvent, does it have to be water? Or is water simply what worked here? Titan is often described as Earth's twin. It has dunes shaped by wind, seas shaped by tides from Saturn's gravity, clouds, rainfall, seasonal cycles. But the chemistry is inverted. The temperature regime is alien. The rocks are ice. The rain is hydrocarbon. It is Earth-like in process, but not in substance. Built from the same physical laws, assembled with different ingredients. Future missions aim to explore Titan in greater detail. Rotorcraft concepts designed to hop between locations could analyze surface chemistry, measure atmospheric composition, and study shoreline dynamics directly. Titan is accessible. We have landed there once. We can go back, and when we do, we will not simply be studying a moon. We will be testing assumptions about life itself. Titan shows us a world where weather operates under alien chemistry, where rivers cut through frozen water rock, where seas shimmer beneath an orange sky. It feels familiar, but everything important is different. Earth's twin, built wrong, or perhaps built in a way that reminds us our version of habitability, may not be the only one physics allows.